Uber's payment system goes down in India. All 4 million daily users are affected. Drivers can't process payments. Riders can't book. Revenue stopped flowing. But here's what didn't happen. The entire Uber platform didn't crash. But here's what didn't happen. The entire Uber platform didn't crash. This is Season 4, Episode 1 of The Breakdown Economy. I'm Tony. Season 3 showed you how to build resilient infrastructure. Today, we're showing you how Uber actually did it, and why they had to make the most controversial infrastructure decision in tech. Trusting multiple cloud providers when trusting nobody is safer. Act 1. The problem that forced change. Uber, in 2015, was a different company, growing 50% year over year, operating in 60-plus countries, billions in venture funding. One problem: infrastructure bottleneck. They were running on AWS. All of it. Every server, every database, every edge case, a single cloud provider, a single point of failure. When AWS had problems, which happened, Uber had problems. Each time, Uber's impact lasted for hours and cost millions in revenue. But the real problem wasn't outages, it was negotiating power. By 2016, Uber was AWS's single largest customer in certain service categories. Amazon knew Uber was locked in and couldn't easily switch. Uber was paying premium prices for services Amazon knew Uber couldn't abandon. Classic vendor lock-in problem. Uber had built too much on AWS, making it too expensive to move, but staying with them was expensive too. In 2016, Uber's infrastructure team made a decision to go multi-cloud. Not because they wanted to, because they had to. Here's why that was controversial. 1. Complexity. You think managing infrastructure on AWS is hard? Try managing it on AWS and Google Cloud and Azure simultaneously. 2. Cost. Managing multi-cloud requires a huge upfront investment in the field of engineering, tools, and coordination. 3. Losing the competitive advantage. AWS has the best tools, best documentation, best ecosystem. Using Google Cloud or Azure means using lower-tier or unknown tools. So why would Uber deliberately choose a harder, more expensive path with unknown tools? Because not choosing meant staying dependent on Amazon. Act 2. The multi-cloud strategy. Uber didn't move everything to multiple clouds. That would be crazy. Instead, it was done with strategic placement. So they selected AWS, core compute and traditional services, EC2 instances, application servers, RDS, relational databases, SQS, message queues, S3, storage. Why AWS? They started there. Most engineers are trained on it. Most tools are optimized for it. Google Cloud was chosen for machine learning and data processing using this BigQuery, data analysis, TensorFlow, ML training, Cloud Dataflow, data pipeline, pub/sub messaging. Why Google? Google's ML infrastructure is best in class. Uber uses ML extensively for surge pricing, routing, and predictions. And finally, Azure was picked for enterprise and legacy services. For some traditional databases, enterprise integrations, compliance-specific workloads. Why Azure? Microsoft enterprise relationships. Some corporate customers require Azure compliance. In the end, it was 60% AWS, 25% Google Cloud, 10% Azure, and 5% their own private data centers. This isn't an equal distribution. That would be stupid. Each cloud handles what it does best. Here's the key insight most companies miss. Multi-cloud isn't always about equal redundancy. It's about strategic dependence. Uber doesn't replicate everything on every cloud. That would cost 3 times as much for minimal benefit. Instead, each critical service has primary and backup, but not necessarily on different clouds. Here are some examples. Example 1. Surge pricing algorithm. Primary, Google Cloud, best ML tools. Backup, AWS, still capable, just slower. If the Google Cloud ML pipeline fails, it falls back to AWS with degraded accuracy, but continues operating. Example number 2. Ride matching engine. Primary, AWS, built there, optimized there, fastest. Backup, Google Cloud infrastructure can handle it if needed, with a 15-minute failover time. Local data centers for ultra-low latency. One cloud failing doesn't bring everything down. Things degrade gracefully. Example number 3. Payment processing. Primary, AWS. Backup, AWS different region. Geographic redundancy within cloud. Tertiary, Google Cloud, completely different provider. Payment is critical. Uber can't afford single provider failure. So it's belt and suspenders redundancy. Now managing this requires obsessive monitoring, so Uber has real-time dashboards showing health of every service on every cloud, cross-cloud latency, cost per transaction on each cloud, and failure rates and error budgets. Engineers can immediately see when a cloud is degrading, can trigger a failover before users notice. Act 3. The real cost. What Uber didn't tell you. Multi-cloud sounds great in theory. In practice, it's brutal. Here is what it costs Uber to run the multi-cloud operation. Cost 1. Engineering complexity. Every engineer needs to understand multiple clouds, not just AWS, Google Cloud too, Azure maybe. There is hiring specialist for each cloud, 200 to 300,000 per engineer. At 10 plus engineers per cloud, that equals 2 to 3 million annually just for multi-cloud expertise. Plus, training the existing team, Uber's infrastructure team grew to 300 plus engineers, not because they needed 300. Managing multiple clouds requires 3 times staffing. Initially, complexity also increased. Incident response that would take 30 minutes in a single cloud takes 90 minutes in a multi-cloud environment. Why? First 30 minutes figuring out which cloud caused the problem. Finally, tool fragmentation. AWS has tools optimized for AWS. Google Cloud has tools optimized for Google Cloud. You need to learn and integrate multiple tool ecosystems. Uber's total multi-cloud cost, estimated at 2 to 3 billion over the first 5 years. That's not infrastructure costs. That's the overhead of managing infrastructure on multiple clouds. So why do it if it costs 2 to 3 billion extra? Because being dependent on AWS costs them more. Act 4. The decision matrix. Why multi-cloud made sense. Uber knew what they were doing. They calculated the economics. Scenario A. Stay AWS-only. Annual AWS spend, 500 million. Negotiated hard, but still steep. Outage risk. Every AWS problem affects Uber. Negotiating leverage. None. Amazon knows Uber trapped. Cost of major AWS outage. 100 to 500 million. Revenue loss, customer churn, reputation. In a bad year with 2 major AWS outages, the expected loss is 500 million. With AWS spend of over 200 million, the outage costs total 700 million. Scenario B, multi-cloud. AWS spend, 300 million, negotiated better with competition threat. Google Cloud, spend, 150 million. Azure spend, 50 million. Total spend, 500 million, same as before, just distributed. Engineering overhead, 500 million over 5 years, 100 million annually. Outage risk, significantly reduced. AWS outage impact, reduced 50%, some services still running on Google Cloud. Expected loss in a bad year with the same 2 AWS outages. 500 million spend, plus 50 million cloud outage impact, plus 100 million engineering overhead equals 650 million total. Multi-cloud costs about the same, but distributes risk and improves negotiating leverage. Plus, Uber now negotiates prices with Amazon using a credible threat of migration to Google Cloud. Suddenly, Amazon is willing to negotiate. AWS pricing drops 20 to 30%. Now, scenario B looks like AWS, $250 million, better pricing. Google Cloud, $150 million. Azure, $50 million. Total, $450 million, which is 20% cheaper than AWS-only. Plus, distributed risk. Plus, negotiating leverage. Economics suddenly favor multi-cloud. Not because multi-cloud is cheaper, because being dependent on one vendor was more expensive. This goes back to Season 3, Episode 1, a real lesson in action. Multi-cloud is about strategic placement and negotiating power, not full redundancy. Act 5, the real-world consequences. Uber's multi-cloud strategy got tested multiple times. In November 2020, Google Cloud regional outage. Google Cloud US Central Region goes down. 1 hour. Hundreds of services are affected. For most companies, catastrophic. For Uber, degraded experience in specific regions. But the platform kept operating. Affected users, approximately 5%, those in the central US region. Revenue impact, approximately 2 to 3% during the incident. Total, approximately $500,000 to $1 million. Had Uber been AWS only, Uber would have been fully down, different failure mode. Had Uber been Google Cloud only, it would have had the same catastrophic impact. In June 2022, AWS EC2 Instance Metadata Service, vulnerability, critical security vulnerability discovered. AWS recommends urgent patching. Uber's response: patch AWS infrastructure first, it's mission critical. Lower priority services second. But some Uber services are already on Google Cloud and are not vulnerable. Net effect: reduced urgency, not everything vulnerable. Faster response, contest fixes on Google Cloud first. These aren't dramatic stories. No outages, no massive revenue loss, just slightly better outcomes because of the distributed infrastructure. That's the actual value of multi-cloud, not dramatic disaster prevention. Subtle risk reduction across many small incidents. By 2024, Uber's multi-cloud strategy is business as usual. Engineers deploy services choosing the optimal cloud. Costs are negotiated competitively. Outages are contained. Did it cost $2 to $3 billion in extra overhead? Yes. Was that more expensive than alternatives? No. Is it still a headache? Absolutely. But it's a strategic headache, not a strategic dependency. Uber's multi-cloud strategy is Season 3, Episode 1 lesson in practice. Not about equal distribution across clouds. Not about copying Spotify exactly. About strategic choice. Being dependent on a single vendor costs more than managing multiple clouds. Next episode, Netflix deliberately breaks systems during business hours to build resilience, and how their engineers actually think about failure. I'm Tony. Season 4 is about infrastructure that works in practice, not theory. Uber's decision wasn't heroic, wasn't revolutionary. It was pragmatic. They identified dependency risk, calculated cost, made an economic choice. That's how infrastructure excellence gets built, one pragmatic decision at a time.